Hi, you guys. Welcome to Data Analytics. All right, so today we are doing something that I'm quite excited about. Not too complicated. I believe everybody can do the work today. So when you go inside your Google Classroom, here you go. You're right here. This is your Google Classroom. Every day when I wake up in the morning, I post your agenda, and you can see it here. And I tell you kind of what I'm going to do. So you can always read the agenda. You can always comment right below. I will answer, or I may not answer. So let me just say, great. And I'll send it to you guys. So you guys see that I'm reading it as well. Okay. So today, if you go under classwork, you guys will see we are Friday. So day 4 lecture note. This is where we are. So when you click on it, here you go. So this is the lecture for today. And I'm also going to post the video right next to it. You just don't see it here because I'm still recording it. And the assessment is right here. So it's just questions and you can answer right below. You read the story, you answer the questions, you send it right back to me, and I will comment. I will comment as I read your answers. And we'll talk in class as well. So this is it. Another assignment that is pretty key is your article reviewing assessment right here. I'm going to make a video about this, but the instructions are over here. The instructions are here already. I think you guys have been placed in group, so your names will appear in the documents, your group members' name, etc. And then the articles as well, they're in the Google Drive, but I will explain a little more. I will make a separate video about article reviewing assessment because it's key as you prep for your business pitch competition. It is key. All right, so I think I can start with day 4 lecture notes. Okay, so day 4 lecture notes, I can start now. Here we go. Okay, I'm going to go back and forth between my iPad and my PC because we are going to do some work on the iPad and some work in a software, which is R. And I hope you guys are ready. Wherever you are, just take a deep breath. In and out, in and out. Okay, I'm going to set up really quickly and we'll start. Pull out notepads, paper, pencil, be ready to take notes. And there's nothing to do that is hard, nothing that we're doing today that is actually hard. It's just a matter of you just following along with me, okay? And jot down your questions. We'll answer them at the end of the class for sure. All right? So let's start. So what I want to talk about today is measures of central tendency, measures of position, measures of variation. Let's see how far I can go. Okay. So nothing here is something that you haven't seen or heard of. What is a measure of central tendency? This is a measure of location. Location, center. All right. What do I mean by that? Those measures of central tendency, they give me an idea of the center of my data. The center, what is the mean, the median, the mode, whether I'm talking about a population or a sample. I'm not going to do this with you. We'll talk about the shape of the distribution for sure, and we can compare the mean and the median. So I only have 2 objectives for you today. How to find the mean, median, and mode for a population or a sample data set. How do we describe the shape of a distribution? And how do we compare mean and median? Those are the 2 bullets underneath measures of central tendency. So, like I said, a measure of central tendency, it's a value. It's a numerical value. It typically gives you an idea of where the center of your data is. If I'm going to say, okay, let me find measures of central tendency for this specific data set, I'm either talking about the mean, the median, or the mode. But what is the mean? So let's talk about the mean. This is not brand new for the ones that have taken or did math or somewhat of a math in high school, whether you're an upper seat or first year university. The mean is your average, right? This is the average. So when you sum all the data entries, divide by the number of entries. So for example, let's say you have a data file that consists of 1, 2, 3, 4, and 5. And you want to find, for example, the mean of this data set. You're going to have to sum all of this, 1 plus 2 plus 3 plus 4 plus 5. That's going to give you, this is 9, 10, 11, 12, 13, 14, 15, 15. And then you're going to divide that by the sample size. Here you have how many data points? You have 5. So you divide by 5, 15 over 5. And that's going to give you the mean. The mean in this case is going to be what? 3 times 5 is, it's 3. I hope my math is okay. What do you guys think? So imagine you have that list of data values, right? 1, 2, 3, 4, 5. When you count all of them, gives you 5. 5 represent your sample size. If you want to find a mean, the first thing you do, you sum all your data points or all your data entries, then you divide by the number of entries. This sigma notation here means add all the data entries or sum all the data entries. So I'm saying the mean is equal to the sum of x over n. This is the population mean or population parameter. Remember what a population parameter is. This is a numerical value that describes your population. And this guy, notice the notation, x bar, that's your sample mean. Notice the notation, x bar, that's my sample mean. So this is a sample statistic because that describes what? It describes my sample. So in this case, when I'm talking about this tree right here, 3, 3, 3, that 3 represent what, people? Think about it for a minute. What is that tree? 3, is it the population mean or the sample mean? What does that 3 represent? What do you guys think? Is it the population mean or the sample mean? It really depends what I told you. I told you n was my sample size. So this guy should be my what? Sample mean. What did I do? I summed first all the data entries and I divided by what? The sample size, which was 5. So I did 1 plus 2 plus 3 plus 4 plus 5 gives me 15. Divided by 5 gives me 3. That's my sample mean. So this is the mean, okay? That's the mean. Take a deep breath. What did I do to find my mean? What's the formula? If you were to say it out loud in English, what is the sample mean equal to? Sum of x over n. Sum of all your data entries over number of entries. Say it to your friend. Sum of all the data entries over the number of entries. Repeat it. Sum of all the data entries over the number of entries. Repeat it. Sum of all the data entries over the what? The number of entries. That's it. You got it. Now let's look at the median. The median is the value that lies in the middle of the data. The values that lie in the middle of the data when the data set is what? Ordered. Usually it's ordered in ascending order from the lowest to the largest. Okay? So it measures the center of an ordered data set by dividing it into 2 equal parts. Now, imagine it says when odd number of entries, we had 1, 2, 3, 4, 5. This is already ordered, yes? Odd number of entry, n is equal to 5. So this is odd. The median is the middle data entry. So look at the middle. There goes your median. But if you have even number of data entries, so 1, 2, 3, 4, 5, 6, then it says the median is the mean of the 2 middle data entries, the mean of the 2 middle data entries, the mean of the 2 middle data entries. So your median is going to be between these 2. So you're going to have to do 3 plus 4 over 2. The mean of the 2 middle data entries. 7 over 2, that gives me back what? 3.5. That's going to be my median. Does that make sense? So the median is the middle of the data. Say it to your friend. The median is the middle of the data when the data is ordered. Say it again to your friend. The median is the middle of the data when the data is what? Ordered. Say it again to the person behind you. The median is the middle of the data when the data is what? Ordered. Ordered. So if you have an odd number of entries, easy. You can just quickly locate the middle. But if you have even number of entries, what do you have to do? You have to take the mean of the two middle data entries. See this? N is equal to 5, so it's odd. So the median will be right in the middle. But here, look, your N is equal to 6, which is even. So now you have to take the mean of the two middle data entries. This is why we did 3 plus 4 over 2. We got 3.5. That's your median. All right. And finally, let's talk about the mode. The mode. Pause and have somebody read it for me. Pause. Let somebody in the audience read. What's the mode? So yes, the mode is the data entry that occurs with the greatest frequency. If no entry is repeated, the data has no mode. If two entries occur with the same frequency, each entry is a mode. So you could have no mode. You can have unimodal, meaning you only have one mode. You could have bimodal, meaning you can have two modes. You can have multimodal, meaning you have what? Several modes. Now imagine this is my data. So what's going to be the mode? Pause. What's the mode? Your answer should be 3. It occurs with the greatest frequency. I only have one mode here, unimodal. Okay, let's take another example. What's the mode? You can pause here too. Yeah, your answer should be 3 and 5. This is bimodal. The data entry that occurs with the greatest frequency. Nice. All right, so let's compare mean, median, and mode. What are the advantages? So all three measures describe a typical entry of the data set. They are all measures of central tendency. The advantage of using the mean is that it's reliable because it takes into account every entry in the data set. Notice you got to sum all of the data entries, divide by n. You get the mean. So you take into account all data entries. You take into account all data entries. That's how you find the mean. But a disadvantage of using the mean is that it's going to be greatly affected by outliers. Greatly affected by outliers. Why? Because imagine you have a data set like this, 1, 2, 3, 4, 5, and then 20. 20 is extreme. So notice, when you're going to find your mean, what is your mean going to look like? You're going to sum 1, 2, plus 3, plus 4, plus 5, plus 20. You're going to divide by 1, 2, 3, 4, 5, 6, 6. And look at what your mean is going to be. 5 plus 20, that's 35 over 6. That's going to give you roughly 6. See, your mean is going to be 6. It's going to be greatly affected by what? By this 6 right here, by the 20. So it's a reliable measure because it takes into account every data entry. But the problem with the mean is that it's greatly affected by an extreme measure or an outlier. So if you have something that doesn't look like your typical data point, you have something that's extreme, your mean is going to be thrown off by it. So in this case, your mean is going to be thrown off by it, but it's not really going to represent the center of your data. No. In this case, you might look at the median to be a better measure of central tendency. I'm going to repeat that again. An advantage of using the mean is that the mean is a reliable measure because it takes into account every data entry. Remember, you're summing all your data entry, you're dividing it by your sample size. Now, a problem with that as well is if you have an outlier, if you have an extreme measure, that is going to throw off your mean, all right? Like in this case, that 20 is extreme. So when I do 20 plus 9 plus 6, I get 35. I divide that 35 by 6. My mean comes out to be 6. So my mean is going to be somewhere here, which is kind of off. It's a bit off. So it's not really the right representation of the center of my data. Do you understand what I mean? So in this case, the best measure of central tendency in a data just like this will probably be the median, not the mean. Because your median, remember, your median is not affected by the outlier. Your median in this case, you just go to the center of your data. No, you go to the middle of your data. So you go to here and here, right? And you're going to take what? The middle here. So you're going to do 3 plus 4 divided by 2. That's going to be 3.5. So your median would be the best measure of central tendency here. Does that make sense? I hope so. But we can talk about it again. So sometime when you have outliers in your data, your mean may not be the best measure of central tendency. The best one may just be the median because the median is not affected by outliers. The mean is. And I showed you why. All right. Take a deep breath in and out. I am going to switch computers, okay? I'm going to switch computers right here because we're going to move into R. So I'm going to switch computers. I'm going to come back to this in a minute, but I'm going to switch right now. I'm going to share screen here on my laptop. Yes, I'm going to switch screen right now and share. Okay. So right now, you should see my screen on my laptop. Yes, you should see my screen on my laptop. Yes, you should see it. You should probably see my Zoom and see some other stuff, but this is my laptop. What I need you to do is maybe now, maybe later. This is where we are. We're going to look at some examples together. Okay, this is where we are. We are right here. Okay, so it says the prices for a sample of round-trip flights from Chicago, Illinois to Cancun, Mexico are listed. What is the mean, median, mode price of the flights? And they gave it to you. They listed all of that here. Now, if you go to, this is a Mac I'm using, so I can just go to applications and I can locate my RStudio, which is right here. I want you guys to pause this video if you can. If you're using your computers, I need you guys to locate your RStudio. I need you guys to locate your RStudio. It looks like this. I just opened it up and there goes my RStudio right there. This is my RStudio. So this represents just like a place where I can see my files, but this is where you code in the RStudio right here. Let me see if I can open it up. It's right here. You code here. So any code that I want to plug in, I'm going to plug it here. Okay. This is where I code. So there goes my RStudio. So let's pause for a minute. I'm going to give you guys about a minute. If you're using your computer, go ahead and open it up and find your RStudio. Open it up just like me. Let's take a minute to do that. Okay, so here goes my RStudio. This is the work we're doing. So the first thing I need to do is I want to find mean, median, and mode. And for that, I need to call a library. It's called library stats. It's like you're telling R, I want you to pull out this library because I'm going to use functions in it. So just copy and paste it in there. Stats is the library I'm calling in R because there are functions in there I'm going to use so I can find the mean, the median, and mode for that data sets. Now, every time you see me plugging in this thing here, it's like a comment in R. I'm just commenting, nothing is going to happen. So I'm just saying I'm installing stat library. So as a coder, you want to code, but you also want to comment so that if somebody goes in your code, they know what you did and why you did what you did. So literally what I'm saying here is install the stat library. That's what I'm saying to R. I'm saying it to you as well, install the stat library. The next thing I want to do is I want to enter my data. So notice what I'm doing here. So I'm saying X is going to be a vector of, and I'm listing my data set. Notice what my data is: 872, 432, 397, 427, 388, 782, 397. So I'm just putting it in a vector or a list, and I'm calling it X. You could have called it anything you want. You could have said, okay, this represents what? Price of flights. So we could have called it price. If you say price, okay, let's put it in small letters, price, okay, and I'm gonna make price that vector right there. You could have done just that. And you can do a lot of copying and pasting. And why do we use R? We use R because it's a free source. It's free and it's open to everybody. So I'm entering my data, enter data. So now I'm calling it price. I'm calling this data price. That's it. And now what do I want? I want to find, I'm saying, okay, let's find the minimum, the maximum. So find the minimum flight price, find the maximum, find the average, find the median, sort the data. This is sorting it ascending order, and then find the mode. That's what I'm doing. So let's talk about it again. So see, I'm saying, okay, I'm going to need you to find the minimum data price or the minimum flight price in that data set called X. I'm going to need you to find the maximum flight price in that data set called X. I'm going to need you to find the mean of the flight prices. I'm going to need you to find the median of the flight prices. Now, why am I sorting? I'm sorting it because I'm trying to figure out if I sort this data from ascending to as in ascending order, so from the lowest to the highest, I'm going to be able to locate my mode. I'm going to be able to know which flight price occur with the most frequency. I'm going to be able to locate my mode. So when you do that, you press enter. Look at what you have. The mean is going to come out to be 388, maximum 872. Mean is 527.87571. Median, when you sort, it's telling you, okay, this guy came one time, appeared in the data how many times? It says one time. 427 appeared in the data how many times? One time. 432, one time. 782, one time. 872, one time. And then it tells you 397 appear how many times? Two times. In fact, this mode function, it doesn't quite exist in R. The sort is actually the one that is going to tell you where the mode is. So by looking at the sort result, it tells you that the mode is what? 397. So this guy here is not going to help you. Right here. Boom. By sorting the data, you are able to locate the mode. So let's remove this right here. Boom. So this is what you get. See that? Pause the video. If you're doing this exercise with me, go ahead and copy and paste this in your RStudio and see if you get the same thing as me. Let's pause. If you're doing the RStudio with me, pause and see if you get the same thing as me. There are people in the audience. Zach, if Zach is there, it can help you. But pause the video and see if this is what you get from me as well. You get the same thing. So just copy and paste it in and look at what you get. And then we're going to go into interpretation. Pause the video. All right. So coming back, now that you have all your results, they don't mean nothing to me if you cannot tell me what they literally mean in English. I have results. Now I had to be able to interpret my results in layman terms. Somebody has to be able to read and know what the heck is going on. Excuse my language. So my minimum is 388. It means what? Remember what you were looking at. You were looking at prices of round trip flights from Chicago to Cancun. So it means the minimum price for a round trip flight ticket from Chi to Cancun is what? 388. Look at the keywords, minimum price. So you have to tell me what is what? It's a minimum price. For what? Round trip flight ticket from Chi to Cancun is what? 388. So this is your what? Sample statistic. Does that make sense? Then the maximum price, see, the maximum price for what? A round trip flight ticket from Chi to Cancun is what? $872. That's my sample statistic. The average flight price ticket, that's the mean. Average flight price ticket from round trip flight ticket from Chi to Cancun is what? $527.86. Nice. Then what else? The median flight price. Median, that's the middle of your data. Yes. Median flight price for a round trip flight ticket from Chi to Cancun is what? $427. Now, what is the mode? The mode is what occur with the most frequency. Listen, your mode is 397. So it means that the most frequent flight price for a round trip flight ticket from Chi to Cancun is what? $397. That's what it means. The most frequent flight price. The most frequent price, that's what it means. Or you could say that if you were to look for a round trip flight ticket from Chi to Cancun, most of the time you will pay $397. That's your mode. All right, we're going to pause right now and discuss with your partner. If there was anything that you didn't understand, ask them, did you get this? Do you have any question about this? Talk about it. Was this thing a bit difficult or was it not? Is it pretty clear? I'm going to give you guys about a minute and we'll come back. All right, people, we are back. Now, back here, I'm going to share my screen again and change my screen to my iPad because I'm going to go over some stuff and then we come back into R. All right, let's go back and let me share my screen again. So I'm flipping from my iPad to my computer, from my computer to my iPad. But I think you guys can follow me. Yes. Yes. Okie dokie. So we did this. We are here. Measures of position. All right. Let's talk about this for a minute. Now, we talked about measures of central tendency. Now we're moving to measures of position. Position. What is my position in my data set? That's pretty much what it is. Measures of position. So here's what I'm going to do. I'm going to talk about the first, second, and third quartile. What is it? How to find it? How to find the interquartile range? What is it? How to represent a data set using a Busky and Whisker plot or box plot? What is it? We're also going to talk about percentiles, how we fracture the data and what it means, how to find percentile using a specific data entry. There are 2 points. I'm going to talk about quartiles. Quartiles. This is when you split your data into 4 equal parts. Quartile. How to find the interquartile range. The interquartile range happens to be the middle portion of your data set. And how we represent that using a box plot. It tells us a lot about the data. And then we'll talk about percentiles or fractals. It's really just fracturing your data in multiple pieces, right? And then how do we interpret those things? So let's talk about quartiles. I'm going to have a picture right here. So here is my data set. Imagine this is my data set. All right. Imagine this is my data set. This is my data set. This is my minimum. This is my maximum. Let's split it in 4 parts. 1, 2. See that? I can't even do a good job. So minimum, maximum, boop, boop, boop. I think I'm doing the best I can do, yes? How many times am I going to do this? Here we go. Minimum, maximum, and then here is going to be Q1, Q2, Q3. So this happens to be 25% of the data to the left, 50% of the data to the left, 75% of the data to the left, and this is what? 100%. There goes my quartiles in blue. This is the 25th percentile, or P25. This is the 50th percentile. This is the 75th percentile. Your minimum is at position 0, is it not? Your maximum is at position what? 100, meaning 100% of your data is to the left. Now your Q1 is at position 25. Your Q2 is at position 50. Your Q3 is at position 75. The entire spectrum represents your data, which is 100%. All right? So if I'm at Q1, to the left of Q1, I have 25% of my data. To the right, I have what? 75% of my data. If I'm standing at Q2, to the left, I have 50%. To the right, I have 50%. Q2 happens to be your median as well. That's the middle of your data. If I'm standing at Q3, guess what? 75% of my data is to the left, 25% of my data is to the right. If I'm standing at the max, it means that 100% of my data is to the left. Does that make sense? These are quartiles. Q1, Q2, Q3. Those are my quartiles. Your interquartile range happens to be the middle portion of your data, or the difference between the third and first quartile. Here we go. So this is it again. Minimum, maximum. I'm going to show you something here. This is a box whisker plot. This happens to be Q1, Q2, Q3. This happens to be your IQR. The difference between Q3 and Q1. The middle portion of what? Of my data. Take a deep breath. Ask your friend, what is Q1? Your friend should say, that's the 25th percentile. To the left, 25%. To the right, what? 75%. Now, ask your friend, what is Q2? What is Q3? Pause the video, ask your friend, what is Q2? What is Q3? Pause the video. All right. So I hope you guys say Q2 is the median, is the 50th percentile. 50% is to the left, 50% is to the right. And for Q3, I hope you guys said that is the 75th percentile. 75% is to the left and 25% is to the right. All right. And the IQR happens to be what? What is IQR? IQR is the difference between Q3 and Q1. It's the middle portion of your data. Okie dokie. Take a deep breath. We're going to switch screen again. We're going to go back into RStudio. All right. And do some work in there. Let's go back into RStudio. We'll do some work in RStudio. So let me switch screen real quick. Okay, so this is where we are. We'll do this work into the R studio and then we'll do some interpretation together. What does it mean? What does it represent, etc. All right. I think that there's nothing here that we're doing that you guys cannot do. Take a minute and let's read this problem together. It says the number of nuclear power plants in the top 15 nuclear power producing countries in the world are listed. So we're talking about what? Nuclear power plants. Yes. It says find the first, the second, and third quartile of the data set. Find IQR as well. But every single time we do something, we do what we interpret. So this is your data, yes? See, you're calling the library stats, and then we're going to call a vector where we enter our data. So this is what we're doing. You could have called that data as anything you want. You could have called it what? We know the number of nuclear power plants. So you could have called it number of nuclear power plants. You could have called it power plants. You could have called it plants or power, whatever. But I'm calling it X. All right. Now, the function quantile gives you a quantile, but you have to tell him what quantile you want. This is why you have 0.25. 0.25 says, I want you to find the quantile of this data set, and I want you to look at the 25th percentile, position 25. Then this is quantile X, 50th percentile, quantile X, 75 percentile. Does that make sense? And notice that when I code or write a code, I'm commenting at the same time. Then I'm telling him, okay, find the IQR as well. So you have a function called IQR, and I'm asking him to sort because I want to see something here. There we go. So once you type all of this or copy and paste, you can press enter. This is what you see. All right. So pause the video and do the same thing as me. Let's come back. Okay. So I'm gonna say that you guys did what I did some way, somehow, yes? So let's start looking at our results. So it tells me that the 25th percentile or QM is 10.5, quantile 50th percentile is 18, quantile 75th percentile is 25.5, IQR is 15. That's what I get. Is that what you guys get? Yep, that's what I get. 104, 20, 31, 8, 10, 15, 19. Make sure I enter all the data. Yes. Okay. This is what we get. All right. Now, what does it mean? What does it represent? How does that help me, etc.? So let me go back into my notes and then let's do the interpretation in there. At the same time, we can grab the box plot as well. So you can do box plot here. Box plot X. That's going to give us the box plot as well. There we go. This is our box plot. A picture representing the 5-number summary. And I will talk about the 5-number summary as well. So let's go in my iPad and let's talk about what we see. You can pause here, pause to make sure you get the same box plot as me. And then we can come back and do interpretation together. Okay, so here we go. So this is what we got. So literally, what are we saying here? We have our Q1 as 10.5, our Q2, 18, which is a median. We also have our Q3 as 25.5, and we have the IQR as 15. That's what we're saying here. And when we sort the data, I'm able to see my minimum and I'm able to see my maximum. Does everybody see that? This is what I see. So if I was to get the box plot, which we did get the box plot. This is what we got. We know that our minimum was what? I think it was 6. Yes. Minimum was 6. And then maximum was what? 104. It happens to be extreme. And this is why you see it in the box plot, because it's not on it, it's outside of it. So this is an outlier. It tells us also that this too, according to the box plot, these are also outliers. And they happens to be what? If you notice, it's probably 59 and 54. And median, we know the median to be what? 18. That's what we got, right? The median was 18. This guy here is your Q1. This guy here is your what? Your Q3. This is your Q2. And this is probably what we have before 54. So before 54, when you sort the data, it's 31. So this guy is probably 31. So this is what we have. Okay. So now the question is, what does it mean, etc.? What I just laid out to you guys is what we call the 5-number summary. The 5-number summary is what we use in stat to quickly describe the data set. We give you the minimum, we give you the Q1, which is your 25th percentile, we give you the median, we give you the 75th percentile, and we give you the maximum. And we are quickly describing our data using the 5-number summary. When I give you a box plot, that's a representation of it. If there are any extreme measure in my data, I will see it in my box plot. I will see it in the box plot. If there are any extreme measure in my data, I will see it in the box plot. So let's go talk about what each one of those measures mean. So notice something. My mean was at 6. So the minimum number of of nuclear power plants, the minimum number of nuclear power plants in the top 15 nuclear power producing country is what? Is 6. So the minimum number of nuclear power plants in the top 15 producing countries is what? Is 6. This is interpreting the minimum. Now, notice if I go to Q1, Q1 is saying what? 25% of my data is to the left, right? It means that 25% or less. So the number of nuclear power plants in the top 15 producing country, no, it means that 25% or less 25 have what? Have 10.5 number of nuclear power plants. It means that 10.5 represent, it just went out of my head. Let me go to maximum, let me come back, because the median represents just the median number of nuclear power plants in the top 15 country is. So the median is the median number of nuclear power plants in the top 15 producing countries is 18. That's the median. Median is also 50%. 25% or less, or 10.5 represent number of nuclear power plants in the top 15 countries. 25% or less number is what? 10.5. I don't understand how come I can't. No, it means what? It means that number of nuclear power plants in the top 15 country, 25% or less, 10.5, half 10.5, 10.5 number of nuclear power plants. Oh, 25% or less. Let's pause this video for a minute. I'm gonna go and look at something really quickly, because for some reason, I am quite confused on how to state it in a very simple way. Let's pause the video while I'm really looking into how do I describe it in such a way that you guys can understand that 25% or less represents something very specific. It represents the number of nuclear power plants. It's not something difficult. It's just that it's not in my head right now, which is strange. So we have 25, the box, da, da, da. So 1/4 of your data, so about 25% of the data entries are less than that, 10.5. So what I'm saying is, all right, so here is my box plot. There goes my median. Minimum, this is my 10.5. So this 10.5 is my Q1. But I'm saying that 25% of the number of nuclear power plants in the top 15 producing country is 10.5. Oh, this is so easy. Listen, y'all, I was making it too complicated. So the 10.5 represent this. The number of nuclear power plants in the top 15 producing country is 10.5 or less. It was as simple as that. Why was I making it so difficult? So notice my Q1, which is 10.5, it just means that the number of nuclear power plants, in the top 15 producing countries is 10.5 or less. That's what it means. Plain simple. I was making it too complicated. So you can imagine for Q3 was what? 25.5. What does it mean? The number of nuclear power plants in the top 15 producing countries is what? Is 25.5 or less. You can round it to 26 since we're talking about number. Maybe you can round it to 26. And finally, your max. Max represents your maximum. So maximum number of nuclear power plants in the top, maximum of nuclear power plants in the top 15 producing country is what? Is 104. Okay, that wasn't difficult. It's just that statistics is a new language. It really is. It really is a new language. It's like you have to speak statistic. So whenever you give summary statistic, you have to be able to know what they mean specifically in your current situation. We were talking about number of nuclear power plants. So what is the minimum? Minimum was what? 6. So the minimum number of nuclear power plants in the top 15 producing country is 6. When we found quantile or the 25th percentile, that represents position 25. It means that 25% of my data is to the left, right? And 75 is to the right. So that number was 10.5. So it means the number of nuclear power plants in the top 15 producing country is, I could have rounded to 11, so it's 11 or less. When I found the median gave me 18. So the median number of nuclear power plants in the top 15 producing country is what? Is 18. That's what we got, yes, 18. Now Q3, same thing. The number of nuclear power plants in the top 15 producing country is 26 or less. Now the median, you could have said something like this. Number of nuclear power plants in the top 15 producing country is 18 or less. Because remember, your median is also your 50th percentile. So 50% is to the left. So maximum was 104, right? So maximum number of nuclear power plants in the top 15 producing country is 104. Now your IQR just represents the middle portion of your data. So most, or you could say that most, the number of nuclear power plants in the top producing country, like they will mostly fall between what? Between that 11 and what? And 26. Because your middle portion is just this. You have 11 over here, you have 15. No, you have 11 and you have 26. So your middle portion is here. So you're basically saying that middle is 50%, right? So 50% of the nuclear power plants, or 50% of the number of nuclear power plants in the top 15 producing country will fall between what? 11 and 25. I hope you guys heard that. I'm going to repeat myself again. So what are we saying about the IQR? We're saying that 50% of the number of nuclear power plants in the top 15 producing country is what? Is falling between, I'm giving Q1 and Q3, 11 and 25. All right, I need you guys to pause and discuss. What is Q1? What is Q2? What is Q3? What is the IQR? What is the minimum? What is the max? And how did she interpret this? How did she interpret Q3? How did she interpret Q1? How did she interpret median? How did she interpret maximum? How did she interpret the mean? And then let's come back in. Now, let's move into the box plot. Now, your box plot is a visual tool. It's a graphical tool. We use it to explore the data very quickly. It highlights important features like the 5-number summary. That's what I told you. For you to be able to graph a box plot by hand or whatever, you need a 5-number summary. You need your minimum entry, your Q1, your Q2, your Q3, and your maximum entry. You're never going to have to do this by hand in real life, just so you know. You use software like R, SAS, Jump, whatever. So here, I'm asking you to draw a box plot with these as 5-number summary. You can do this on your own. I'm not doing it, okay? In your own time, go ahead and throw it out on your own. I will advise you to get like a line going here. Let's say you go into increments of 4. So this is going to be 10, 14. I'm just helping you, okay? 18 plus 4, we're what? 22. Just go in increments of 4 till you get to 31, and then your max, make it way, way far. 26, 30, and then you have what, 34, and you make this guy maybe 104. But we know this is going to be an outlier. We know 104 is extreme, it's going to have to be an outlier. So your mean is going to be somewhere here. Your Q1 is going to be somewhere here. See, I'm helping you guys out. Your Q2 is going to be somewhere here. And then your 31 is somewhere right here. See? And there goes your box plot. It's as simple as that. Now, for goodness sake, I'm gonna just do this. But if it was in a software, they probably won't have the whisker go all the way to 104. They'll probably stop before 104. But here we go. So this is quickly giving you your 5-number summary right here. Okay. Very simple. And then depending on what situation you're working in, you start interpreting it, because all of us can put the code in the computer, but the key is to be able to tell me what it means according to the scenario in which you find yourself in. Okay. All right. Pause the video right here and have you guys do it in your notepad. You do it yourself. Let's see if we get the same thing. Just throw out something. Draw your box plot given your 5-number summary. Let's pause. I hope you get the same thing or you compared it with your friends. But here we go. So there goes your box plot. We found this in the RCran or RStudio. We could also get the histogram by plugging in this. This is the code for histogram. Hist meaning I'm calling the function histogram. Get me the histogram of data set X. So here we go. See, even when you look at the histogram, this is telling you you have an outlier right here. You have an extreme measure. So this is what it looks like. This is what you see. If we were to lay a smooth curve, this is what we're going to see. Are we all on the same page? It tells you that you have a high concentration here. Your data is highly concentrated over here. And when you look at your data, really, most of your data are right here. See, most of your data should be right in here, because your 7 is there, 7 is there, 8 is there, 10, 15, 19, 18, 11, 6, 17, 18. So this is most of your data. So most of your data is in that first bar. That's why it's the highest bar. And then after that, you have some data here and then some data over here. And then you have an outlier right there, 104. So there goes the histogram. You can also pause right here and see if you get the same thing as me by plugging histogram in your RStudio. So plug this guy in RStudio and see if we get the same thing. Do we get the same thing? Let's just pause. All right. One interpretation of this is most number, like more than 50%, I'm going to say, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, more than 50% of the number, more than 50% of the number of power plants. What is it? The number of nuclear power plants. Most of the number of nuclear power plants in the top 15 producing countries lie between what? Lie between 7 and 20. That's one interpretation. When I say interpretation, you could say an extreme outlier or an extreme measure, or an outlier here is 104, and you can tell, or you can say that it's unlikely. It's unlikely for a producing country, right? It's unlikely for a producing country to have 104 nuclear power plants. So if you have a country that has 104 nuclear power plants, it's unusual. But there is one, obviously, but it is unusual. So that's another interpretation, right? One of these producing country has an unlikely number of, so one of the top 15 producing countries has an unusual amount of nuclear power plants. It's unusual. It's very unusual. But there is obviously a country that has an unlikely amount of nuclear power plants. Okay? There are so many things we can say. You can talk about, there are many interpretations here when you look at your plots. Whether you look at the histogram, whether you look at the box plot, right? It's also unlikely for a country to have 59 or 54 nuclear power plants, because guess what? They are all outliers. They are all outliers. It's unlikely. It is unlikely, but it's obviously something that exists. So 2 of the top 15 producing countries have unusual amount of nuclear power plants. You're going to write 54, 59. Okay. 2 of the top 15 producing countries have an unusual, have unusual amounts of nuclear power plants. 59, 54. It's unusual, according to my box plot. When you see those dots, means they're outliers. So when somebody's asking you for an interpretation, my interpretation could be different from my neighbor interpretation. But as long as it represents the data, we are both right. So I could have said, oh, according to my box plot, the minimum number of power plants, that a country, a top producing country could have is 6. My friend could say, oh, according to my box plot, the maximum number of power plants that a top producing country can have is 104. Somebody could say, oh, but 104 happens to be unlikely, right? Since it's an outlier, it's an extreme value. So it could say one of the top 15 producing countries have an unusual amount of nuclear power plants, 104. We're all going to be right. So pause this video and come up with an inference. Come up with, because these are inferences, just so you guys know. What I gave you box plots, right? Which is visual representation of my data. This is descriptive statistic. I gave you histogram. This is still visual, right? Descriptive statistic. Now, when you have those two, what do you do with it? You got to interpret, correct? You got to infer from it. Now, when you start coming up with these interpretation, you're moving into what? Inferential statistic. All right. So you can pause this video and really just start inferring from what you see. We come back. But I hope you guys got a good discussion. All right. So percentile and other fractals. So we have quartiles, we have deciles, we have percentiles. We know quartiles is dividing it into 4 equal parts. Deciles, you're dividing it into 10 equal parts. Percentiles, you're dividing it into 100 equal parts. So the same example again. All right, percentiles is just position about the 100, right? So your minimum should be position 1. Your maximum should be what? My maximum is going to be position 100. Okay. So it says the number of nuclear power plants in the top 15 nuclear power producing country in the world are listed below. Find the 40th percentile. I also have the 90th percentile and interpret. So let's switch screen really quickly and then we can interpret from this screen as well. Let's go back into our R. Okay. Shoot. Sorry about that. That's not what I'm looking for. Man, everything is opening but what I'm looking for. Okay. Let me open another one. Everything opening but what I'm looking for. All right, here's what I'm looking for. Okie dokie. So we are right. Bear with me. Man, we have days like this. Okie dokie, we are right here. Percentile and other fractals. Same data, copy and paste. Same data. Remember, we did the histogram, so you could do hist. We get the histogram right here. You have the same thing as me, hopefully. Now you want 40th and 90th percentile. We use the quantile function to find each of those percentiles. Just copy and paste percentile. So it's telling us that the 40th percentile is 16.2. 90th is what? 57. Does everybody see that? So how do we interpret? Okay. So how do we interpret? We wanted 40th and 90th percentile right here. I also wanted a histogram of X. There we go. 40th and 90th percentile, this is what we have. What's the interpretation for it? Remember, if it's the 40th percentile, it's the 40th position. So 40% of my data is to the left. If it's the 90th percentile, 90% of my data is to the left. So it means that 40% of nuclear power producing countries have what? They have 16 nuclear power plants or less. So 40% of, I'm just going to copy and paste of the top. 40% of the top 15 nuclear power producing countries in the world have what? 16 nuclear power plants. Yeah, that's it. And then for 90%, 40% or less. That. And we have 90% or less, have how many? 57. Okie dokie. These are the interpretation. Any questions about this? 40% or less of the top 15 nuclear power producing countries in the world have 16. 90% have da da da. Can you pause the video? But before you pause the video, can you guys find the 70th percentile and interpret it for me? You guys find the 70th percentile and interpret it for me, and let's come back. Find the 70th percentile, interpret it, and let's come back. So pause, find the 70th percentile, interpret it, and let's come back. Okay, let's see if you guys get the same thing as me. So you code it in. Okay. I didn't code it nice. I needed to put 0.70. Here we go. It gives you 19.8. So if it gives you 19.8, then when you interpret it, you have 70%. 19.8 is almost 20. 70% or less of the top 15 nuclear power producing countries in the world have 20 nuclear power plants. Very nice. So this is where we are. All right, take a deep breath in and out. And we'll talk about the shape of a distribution. Take a deep breath in and out. We'll talk about the shape of the distribution. I'm going to switch screen. Once you see my screen, you give me a thumbs up wherever you are. We'll go to our iPad. Okay. So now let's talk about shape of distribution. Now we could have many shapes. Remember this histogram right here when I laid a smooth curve. It was not centered in the middle. It was more to the left, yes? Okay. So there are many shapes of distribution, mainly symmetric. Symmetric is centered into the middle. Y'all see that? It's bell shape. It's like a curve. It's like a bell curve. Or it's like do you know what a bell look like? It's symmetrical around the mean. So if I put a line right here, imagine you put a line there and you fold your paper. You're going to have a reflection, right? Like a mirror. The left part is going to be similar to the right part. So this is symmetrical. And when you have a symmetric distribution, your mean happens to be equal to your median, happens to be equal to your mode. Tell your friend, symmetric means mean equal to median equal to mode. Say it to your friend. Symmetric means mean equal to median equal to mode. Say it to your other friend. Symmetric means mean equal to median equal to mode. So if I have a symmetrical distribution, my curve is going to resemble a bell curve. It's going to be like a bell. If I place a line in the middle, then if I fold my curve, the left side is going to be equal to the right side, or a mirror of the right side. And my mean is going to be equal to my median, is going to be equal to my mode. Uniform. Notice the uniform distribution is flat. Flat, flat, flat. There's no mode. The mean equal to the mode. All entries or classes in a distribution have equal frequencies, symmetries. It's also symmetric because the mean equal to the median, but the only difference is that you have no mode. So uniform distribution. Now here, notice what's happening here. So this is called the tail. Imagine a dog and the tail is flapping, flip, 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 flip. Now the tail is on the left. So this is called left skewed, or skewed to the left. Skewed to the left. So this is a skew to the left distribution. If it's skewed to the left, notice what's happening. The mean is less than the median, is less than the mode. And if it's skewed to the right, like what we had earlier, like so, your tail is to the right. That's why we call it skewed to the right. Here you have what? Mode less than the median. less than the mean. Now, why am I giving you all this information? Like you should say, Dr. Joe, why are you doing all this? Come on, it's too much. But why am I giving you all this information? I'm giving you all this information. Why? Why? Mode less than the median, less than the mean. Okay, let's go back here. This is skewed to the what? Skewed to the what? Skewed to the what? Skewed to the right. Your tail is on the right. So according to what I know, my mode should be less than my median, should be less than my what? Mean. Mode less than median, less than what? Mean. Mode should be what? Less than median, less than what? Mean. You can check that. Take a minute and check. Give me your mode. Pause the video, find the mode, find the median, and find the mean for me. Go into R and do median X, mean X. You don't even have to because you already have the median, right? You already have Q2. But do mean X and then sort X to find the mode. Come back in. Go back and look at the sort. How we get the mode. Go back and look at it. I think it was sort table X. That's going to help you. So when I use R, I did this. I did mean X, and it gave me 26.47. I'm rounding. My median is Q2, and we already know that the Q2 was 18. And then my mode, what did I do? I did sort table X, and it gave me the mode at 18 as well. Remember, the mode has to be less than the median, has to be less than the mean. And somewhat it is that. My mode is here, my median is here, my mean is where? Right here. So somewhat this works. It's skewed to the right. So if I'm to give you the 5-number summary along with the mean and the mode without giving you a histogram, you ought to be able to comment on the shape of this distribution. Let me say that again. If I give you the summary statistic along with what? Along with the mode and the mean, if I give you all of it, you ought to be able to give me back what? To comment on the shape of the distribution without even having to plot it, because you know what? You know that if it is symmetric, mean is going to be equal to, median is going to be equal to mode. If it is uniform, mean equal to median, there's no mode. If it is skewed to the left, mean is less than median is less than mode. If it's skewed to the right, mode is less than median is less than mean. And that's that. And that is that. That's really what I wanted you guys to kind of grasp, Now, we have to do measures of variation. I don't know if we have enough time, but let's see if I can cover a little bit. She can pause the video, but we can continue tomorrow. If we're going past time, she can look, and Michelle can look and let me know. But here, what I want to do in measures of variation is really just to talk about the range of a data set, standard deviation, coefficient of variation to compare variation in different data sets. I want to talk about this. And so let me start with the range of a data set. We can continue tomorrow, but let's start with the range of a data set. This is the difference between the maximum and minimum data entry in the set. Your data must be quantitative. The range is equal to maximum data entry minus minimum data entry. Point blank simple. When we talk about standard deviation, This is one of the most common measure of variation. Variation, we talk about dispersion of the data. How dispersed is my data? How volatile is the data? That's variation. Variation is dispersion or spread. How spread out is my data? Do you guys understand what I'm saying? So let me repeat that again. Now, when I talk about standard deviation, I talk about one of the most common measure of variation in statistics. Measures of variation. What is variation? Variation is spread of your data. How spread is my data? What is variation? Is dispersion. How dispersed is the data? What is variation? Is volatility. How volatile is my data? Now, the standard deviation measures how your data is around the mean. How concentrated is my data around the mean? That's why I talked about spread, right? Now, the more concentrated the data is around the mean, the smaller your standard deviation. Now, if your data is so spread out, the greater will be your standard deviation. Yes. Let me give you an example. See this? Your data is concentrated here. Your mean is at 0, and your data is right there. Your mean is at what? Your mean is at 5. And all your data is where? Right at 5. That's why your standard deviation is at 0. All your data is concentrated in this. Now look at this. Your standard deviation is at 1.2. Now you see a little bit of spread, just a little bit. But it's pretty centered around the mean and it's symmetric. Now look at how when your standard deviation increase, look at the spread. Look at the spread. It's well spread out. Hence, your standard deviation is increasing. So as your standard deviation is increasing, your spread is also what? Increasing. If your data is concentrated towards the mean, your standard deviation is going to be small. It's going to be what? Small. Let's look at some other stuff. Now, the way we find the standard deviation is by using this formula. I'm not going to ask you to memorize any of this because there's no point. In real life, we use softwares, all sorts of calculators, all sorts of programs to do this. So there's no need for you to memorize, but we can talk about what the formula says, what it means. What do you have in there? So first you have the mean, right? So calculate the mean. And then find the deviation of each entry. The deviation is what you see here in yellow. So you take each data entry and you subtract it from the mean. So the deviation is that. So if you have, for example, 1, let's say the data is 1, 2, 3, and 4, 7, 8, 9, 10. So it means that my X bar is going to be 3 plus 4, 7, 7 plus 3, 10, 10 divided by 4. Ugh, it's not a beautiful number. I don't like it at all. 10 divided by 4, let's just move on with that. That's 2.5. So now, for me to find the deviation, I need to take 1 minus 2.5. That's it. So the deviation is, you do each one of those. So 1 minus 2.5, you're going to get negative 1.5, negative 0.5, 1.5, 2.5. Once you find the deviation, then it says square each of them. You take them and you square. Them and you square. So you square all of them. It gives you the square each deviation, and then you sum. So when you square, then you can sum. So 1.5 square you're going to sum all of them. Once you sum all of them, then you can divide by what? N minus 1. N is how many? 1, 2, 3, 4. 4 minus 1. So once you have the sum, you divide by N minus 1. That's going to give you the variance. Once you square root, and then you're going to square root that ratio. You're going to get the standard deviation. That's just an example, just for you to see. Okay, I want you guys to stop and try to explain the process to the person next to you, or explain the process to each other. And let's come back. How did I find the standard deviation? What does xi minus x bar mean? What do you start with? What is the first step? What is the second step? What is the third step? And her numbers, do they pan out? Stop the video and explain it to the person next to you. Okay, to finish up today, we can do art tomorrow, but to finish up today, click on this story right here. We are going to look at this story, and we'll throw out some key things. So you guys are going to read this story, and then we'll pull out some key facts and discuss them. Okay, discuss them. So I'm going to open it up into what I usually open my stuff in. So let me open it up here. Okay. So we're going to read this story together, and then we're going to pull out from this story the key important fact about standard deviation. These are the questions you need to answer. What is standard deviation? You know, what important information the standard deviation gives you? How important is it? Why do we calculate standard deviation? So why do we calculate the standard deviation of a data set? I'm going to post this in Google Classroom. You will answer in Google Classroom. And we will come back and discuss. That's it for today. We'll start back in R tomorrow, but that's it for today. So I'm going to be posting this in Google Classroom with these questions. You guys will comment in there. So I will post it as a question. You guys will comment in there, and then we'll come back together and I will answer your questions. So if Ms. Shania paused this video right now, is to allow you guys to go into Google Classroom and actually see this question and answer in Google Classroom. And then she will allow me to come back in and answer your questions. That's it for today. All right. So see you in a little bit.